this workshop on CEE perspective, so Central Eastern Europe perspective on robotics and how we can develop. And we've got two speakers, except me. We've got Petr from Czech Republic, from Prague, and Andrei from Romania. And they're going to give the presentation, so we're going to learn what they do at their labs, and then we're going to discuss how we are similar, what is different in our labs, and how we exploit those differences to make things stronger. And the first speaker is going to be Petr.
So hello, my name is Petr Čížek and I'm from the Czech Technical University in Prague, Faculty of Electrical Engineering. And today I would like to present you some of the things that we are doing regarding mobile robotics at our lab. So I will start briefly some information about me. So I got a Bachelor in Engineer at Faculty of Electrical Engineering from Cybernetics and Robotics, and now I'm at fourth year of PhD, working on finishing my PhD. But I participate in research activities and in the lab activities already from Bachelor, which I believe is not that traditional. And what is my current topic is locomotion control and learning from experience with hexapod crawling robots, multi-leg crawling robots, and see them in the video. So quickly about our university. So Czech Technical University is one of the oldest and largest technology institutes in Europe. It has been established in 1707, and today it has 8 faculties and 5 institutes, including Czech Institute of Informatics, Robotics and Cybernetics, and at least on 3 of these institutes and faculties, robotics are being studied and researched. So, me particularly, I'm from the Center for Robotics and Autonomous Systems, which is an interdepartment laboratory at Faculty of Electrical Engineering, and we are mostly interested in mobile robotics. And the Center for Robotics and Autonomous Systems consists of 3 individual labs. First lab, my lab is Computational Robotics Group. We are mostly doing things regarding data collection planning and long-term autonomy. Then there is a Vision for Robotics and Autonomous Systems group, which is a group that came from Center for Machine Perception, which is very well known in the world, and they mostly study environment sensing and perception of the robots, or the robots perceive the environment. And last lab is Multi-Robot Systems Group, which mostly work with unmanned aerial vehicles, drones, and they are doing swarm robotics and multi-robotics research. So altogether there are something like 11 or 12 researchers, professors, and something like 20-25 PhD students. And we are taking care of more than 50 undergrad students. So I could list the individual topics more in depth, but I've been told by Christoph that one of our assets that what we do, and it is not that traditional elsewhere, is that we are taking part in robotic competitions. So we decided that I will tell you something about robotic competitions. So robotic competitions, they can be divided into 3 categories. I will start with the first one, which are students' competitions. We have at the Czech Republic, at our university, tradition of student competitions, where the students build their own robots, mostly from Lego, and then they compete in different tasks. For example, a maze, like going through the maze, the robot that goes through the maze, or go on the line, build a bridge, or collect balls. And up to now, it started in 2009, and up to date there are already 70 teams from the whole Czech Republic, from also high schools and elementary schools involved in this project. And it's very nice that actually from the lower education the students get to know robotics and play with robots, and it's mostly therefore for motivation and getting experience. What are next robotic challenges? There are so-called amateur competitions that are like local. In Czech Republic we have few of them. Here I am considering Robotour, which is a competition for autonomous delivery of an object from place A to place B in a park-like environment. And as we are in Czech Republic, we can deliver on a beer keg, so nothing else makes sense. And the task is not to get off-road and not to hit obstacles. So it started in 2007, this type of competition. We have in our labs, we have won it 3 times in a row. And it's very nice source of technical progress and source of scientific ideas, because from this competition, actually, when you start to solve it, you are solving problems that also regard to autonomous vehicles, autonomous driving, planning, delivery, and so on. So it's quite relevant. And one of the things that I would like to mention here, which is like a direct conclusion, but what is directly presented from these challenges is long-term autonomy, because when you are going on the roads in the park, they can change from day to day. And one day you have sunny weather, on the second day you have rainy weather, or the snow falls down. So one of my colleagues started to work on this topic, and nowadays he has a really nice framework for robots like thinking and moving in 4-dimensional space, like 3D, and also considering time in its decisions. So it makes the robot thinks about semantics of the environment and how the robot can actually move in the environment and how the environment changes throughout the time, like day-night cycle or the processes that are going on in the environment. So this is one of the nice examples of how can robotic challenge actually influence the real scientific research with great results. And what are like the most significant challenges that we are participating in are the international competitions. These international competitions are large, research-oriented competitions, mostly towards boosting technological progress in some area. And usually the organizers are big organizations, research organizations or universities, and they put a lot of money into it. So there are high prize money, and some of the teams are usually funded to work on this and to work on these challenges. And we have 2 major successes in last 3 years, and that's Mohammed bin Zayed International Robotics Challenge, which is a challenge for autonomous drones, where there were multiple tasks. First one was to cooperatively collect objects in the field using drones, and the second task was to autonomously land on the moving vehicle with a drone. And the guys from our team won the first prize in the autonomous data collection, won the second prize in landing on the vehicle, and also there was a grand challenge where there were 3 tasks that need to be done at the same time, so they scored third in competition of major world universities and major teams from the world, so it was great success. And our last result is from DARPA Subterranean Challenge, which is a challenge that was held this August in Pittsburgh, and it's organized by DARPA, which is like major army research organization in USA. And the task is to find objects in the underground environments. It's a search and rescue. It's towards search and rescue. And you need to go into the tunnels, mines, underground, and find their objects and report their precise position back to the base. And we scored third overall, and we are first like non-funded team, as I were talking about, that some of these teams are funded. They got a lot of money for development of their systems. We didn't get any money. We had to self-fund this project, and still we scored third overall in the competition of, again, like major institutions and major research institutes. So it was nice success. And again, it is motivated, or the things behind, because we need to somehow comply with the research. So the research behind are data collection, planning, exploration, and traversability. Like the robot has to know where to go, how the robot shall divide the environment, because there are 8 kilometers of tunnels. So with single robot, it is impossible to explore. You need to have more robots, how they should divide the environment, and what terrains are traversable and not. So a lot of these things can be studied that are beneath these results. And also, what is very important is that the robot has to be really reliable, because you have to have 1 hour plus of fully autonomous operation of the robot. So the robot starts at the entrance to the mines and it goes in, and you know nothing about it. So the robot has really to be autonomous, and the reliability of the system has to be really on a high level. So some conclusions. The robotic challenges themselves are a great source of experience. They help to get recognition in the community, because if you compete with the major research institutes and you are good at it, they start to notice that there is even someone from Czech Republic or from Eastern Bloc that can do the stuff as well. And regarding the competition itself, the robot has to be reliable and easy to use, because you have no time to waste. And again, as I demonstrated on these 2 examples, the technical issues that are met on the way towards the competition can be a great opportunity for deep scientific results and scientific challenges. So thank you for your attention.
So we leave some time at the end for the questions, but now we move on to the next presentation, next presenter.
So my name is Andrei Dmitriev from the University of Bucharest. We're like, in many ways, the new kid on the block regarding robotics, because short introduction, the University of Bucharest is one of the oldest universities in Romania. It is it has 20 faculties, so it is not a technical university. It has a technical faculty, but the idea is that it also has social sciences, literature, psychology, and so on, chemistry, physics, and actually physics is one of the strongest we have. And this is one great advantage, because most of the research we do is interdisciplinary, as you will see further. But one of the cool things we have at the Faculty of Mathematics and Computer Science, where I'm from, is that we have great alumni support. So I'm not sure, does any of you, have you seen UiPath before, or the Defender? Have you heard of it? UiPath is actually the first unicorn we have in Romania. Unicorn is a company valued at over 1 billion. Recently it's been valued at 7 billion. And Bitdefender, maybe some of you know it from the antivirus. It's they have a lot more things than the antivirus, but that's the most popular one. But the idea is that both of the founders are ex-students from the university, and they invest quite a lot, because we don't really get public funding, not that much, and it's great to have private funding so far. Actually, the CTO of Bitdefender is one of the he's a PhD student, because he decided really at some point in his life he had to choose between business and research. He chose business. He did it quite well. He's part of a 600 million company, but now he wants to start research again. So that's quite cool. This is my team, and it's actually my greatest asset. We had because we're the new kid on the block. We started 2 years ago, but we had a continuous growth. You can see that most of them are quite young. They're all straight A students, some of the best there are, and they're very dedicated. And I'm happy. I mean, all the money in the world doesn't do what they do, basically. One of the best research part we have is Măgurele Research Institute. It's the largest in Romania, the largest scientific campus. It has over 2,000 researchers. The main area, although there are many research areas, you can see the main one is physics. We have the extreme light infrastructure, which is nuclear physics, which is basically the biggest laser in the world. It's quite cool. And they do also, we do in partnership with them some summer schools as well. So for example, this year, this wasn't in partnership with Mogurele, but this year we had Eastern European Machine Learning Summer School, which was really good. We also had Imagine Healthcare, which is focused on bringing technical and medical people together. As you'll see at the end, this provided some really nice results. And we also, because robotics was not popular, was not traditionally popular in Romania, we also had to invest a lot in high school students. So because of that, with Mogurele Research Institute, we do some summer schools for them. We try to model Geneva on this, if you know it. The idea is that you don't really do a simple summer school, you do a complicated one, and at the end, maybe you provide you write a research paper that the high school students contribute to, which is quite cool to do at such a young age. So for example, some of them, the first one was actually a weather balloon. They had to design the balloon, simulate flight paths, and it was a complete success. We were quite proud of it. And the second one was a classic, but it was very good for them to have an introductory part to robotics. It's an automated green wall. But the idea is that here they also did research studies on pollutants as well. And the third one was, this is actually one of the projects I love the most because I was quite impressed they did it. It's a 3D printed microscope completely. And I didn't even knew you could do that until they did it. But the point is that they did print the microscope, but after that they did research with it. So they did. I wasn't part of this research itself. I only helped on the robotics part. But basically they did research on how they react to different lights, and after that they did machine learning for automated detection. And one of the other cool projects that they did was a replica of the Mars rover. It was actually functional. I'm not sure, maybe not at the same quality, of course, but it was completely functional, so it's not just for the looks, of course. So, for my part, I founded the new book Robotics. We have one of the main advantages we have is that flexible and supportive leadership. So basically, when we had the idea of robotics, they're like, sure, let's do it. They're not, most of our teachers are not arrogant because when I did this, I was in my last years of studying masters. We have 3 new robotics labs, one introduction to robotics at innovation lab, which is focused on applied AI, and also we encourage them to do spin-offs, and one 3D printing lab. And all of them were mostly privately funded from the companies that you saw before and something else. But we've also had a steady growth of 3 times, basically, in the last 3-4 years, and we expect that to keep increasing or at least stay. Well, because we started from scratch, we took a look at open source projects, which I encourage you to do as well. This is a good project that we are working on improving a lot. So it's the e-enable project, which has the 3D printed prosthetics. The idea is that these are mechanical, but they could really use to be motorized. So we are working on that, and when we finish the project, we want to publish it and make it open source as well for everyone to use. Because this is one of the things that actually advanced with 3D printing and with the advent of technology, because everyone at home can do one of those and you can help someone else who is in need. Another project in the same area is exoskeletons. This is actually quite harder because with 3D printed prosthetics, you're lacking a hand. It's quite direct, although sad, but you want a replacement for that. But with exoskeletons, you have a condition, which can vary, can be many conditions, and the idea is that an exoskeleton can actually, in some cases, worsen your condition instead of improving it. So this, although good, and it's a really good starting point for studying, it's very important to do it in partnership with the medical side of the patient. Okay, so in the end, apart from the robotics team, we also have a well-centered AI team that's focused on the pro dean Poznan Alexeev, who did his PhD at the ETH Zurich. We had in Romania, I'm not sure if it was the same in Poland at some time, but we had a huge brain drain, but now that is coming back, basically. It's a lot of people, so for example, all the summer schools we did on machine learning were in partnership with DeepMind Google. That was quite easy to do because lots of them were Romanians. So yeah, we have a new specialization on robotics and AI, and one of the things we do, and we actually took example from Poznan on this, so congratulations, is we're going to build a new center as well, because our building is really cool, it's really old, historic, but if you want to be like this huge robotic arm, it doesn't really work. I mean, it's steady, but still. And we are highly focused on entrepreneurship through the Innovation Lab program, which is one of the biggest in Europe. I think it's the biggest in Central and Eastern Europe. It's it's a pre-incubator program done in partnership with the US as well. And yeah, it also has a research side where you encourage, basically lots of research ends up being just paper. So we encourage to have a business side as well, so it will be self-sustaining. Like, that's it.
So as we are here in those buildings, I will not continue about telling about the directly about our university. I will just focus on our laboratory. So this is me. My name is Christoph Alas, and our presentation was jointly done with my colleagues. So regarding the team, we have something like 29 staff members and 8 PhD students, and this is my focal point and the thing that I would like to mention, that we are really focused on international cooperation. This is the short list of the different universities around the world that we are working with, spanning from Australia to South America and also in Europe, and this list is expanding. Regarding the research, we are mainly focused on autonomous mobile robots. There's a huge group doing that. And we do indoor and outdoor navigation. And this is for wheeled and legged platforms. So that if you want to see the legged platforms, they are outside, so you can see how they walk. And one of the focal points is terrain perception. We also do aerial robotics. So there's a huge group doing the custom-made drones, which, for example, can carry 20 kilos, which is not that easy to get. And on top of that, we have the localization in GPS-denied environment. So when you are in the building, your GPS is not working, so we have to cope with that, how to localize in the building. And this is directly the next topic, large research topic, which is simultaneous localization and mapping. So we do this from 2D and 3D data, so RGPD, and also we do 3D visual odometry and visual span. We also do computer vision, but different taste of it, so not on the huge servers or in the cloud. Our colleagues are focused on having those things working on really tiny machines, so we can put this on the robot or on the drone. So we have little power and also little computation, so how to do it fast with scarce resources. There's also a group doing the human-machine interfaces, I mean here biological interfaces, so they work on the signals, so they can, for example, control the robot from the signal from the brain or from the hand. So we are controlling the hand from the measuring the signals on our muscles at the hand. And we also do machine learning because it's, I think, impossible to do robotics right now without any taste of machine learning. So we are focused on deep neural networks, for example, for street images segmentation, but we also do recurrent neural networks, and this is done for terrain classification. So we just touch the terrain and we know what kind of terrain it is. And we've got 4 ongoing projects right now, and I will comment on each of them now. So first one is about manipulation and how to do grasping and moving of elastic objects. So we are mostly focused on tactile perception, so what is happening with the objects when we touch them. And our industrial application is assembly of mechatronic systems. So we want to put some cables in the boxes, or we want to put the casket or anything like that. So another project is about robot coworker. So the robot which would work in small and medium enterprises. So this is not like full-blown production. You've got people who are working in different parts of of your factory. And for example, we want this robot to move from one point to another, do some tasks, and then move back. So this is another project. These are all funded from our national governmental money. And then we have a joint project with colleagues from Oxford, ETH, Edinburgh, and PISA, and 2 startups. And we are working on walking machines. So if you go outside, this animal is standing close to the entrance, so you can see the robot walking if you want. So we are working also on the sense of touch and how we exploit those signals for better walking. And we are also working on using those robots underground, so in the mines and in the tunnels in the city. And the last project, but I think not least, is the cooperation with our industry partners, so it is Solaris, bus and coaches, and we are working on the support system for the drivers so they can precisely park beneath the charging station. So the Solaris is really good in providing electric buses, but you have to charge them, and how to do precisely dock beneath the charger is quite a challenge. So we are trying to help in this respect through this project. And I think I'm coming to the end of the things that I'm doing. So we are now reaching the point of panel discussions, where I'd like to ask two of my guests to sit here and with a microphone. And we're going to discuss some topics related to our workshop. So first point is I would like to ask is about what is your strength? So you already mentioned it, but to summarize, just like 2 or 3 sentences about the strength of your group, let's say.
Okay, sure. So basically our strength is split. One of them is great alumni support and private funding. Another one is a great young team, which is very enthusiastic. Basically, when you don't have this, people get really enthusiastic about it, and great support from the leadership. And the third is that since we were one of the last to do this in our area, we have a lot of great examples. So people already tried, they went through a trial and error, and we already have that information, so we can build on top of it.
So on my side, it's definitely the leadership, the support from leadership, and across our team. We have different skills, and these skills are complementary, so we can work as a team together, work on these challenges, work on the topics that we are pursuing, and it's really no big competition inside the team, so this is like a nice feature.
Okay, so good leadership plus people working together. Okay, so on my hand, I will say that our strength is this international cooperation. I really focus on that, and I'm expanding because one of the ways of getting the recognition is to take part in the competitions, but other is to contact as many people as possible and start to have projects with them, joint papers, so it's give you visibility. Also for the visibility of other labs. If they are visible, you are like getting also visibility thanks to them. Okay, so we've got one more question, next question. So what do you think is missing compared to the big labs? I mean like the labs like having like 50, 100 people, and let's say US, all those big names. Maybe you are already a big name, but do you think there's still something missing? Or stopping you to be bigger?
Well, in our lab, we have like problems to get new people, especially postdocs, to work with us because there are few professors, and right now it's getting better, but now there is quite a lot of PhD students, but we take care again for a lot of undergrad students. We teach, we do all this stuff, which I believe that can be like done by, let's say, lecturers in the university and so on. So one thing is getting new people and good people into the research. And
yeah. Okay, thank you. And Andre?
Sure. So from our side, basically, the big labs are the ones that are missing, right? It's hard to compete with the huge names. For example, I'm not sure if you saw, but MIT invested 1 billion in AI. That's like way, way over the top compared to us. But we're getting behind on that with the new campus that we are building. But also, one of the things that we're missing is international cooperation on the robotics side. So we have that pretty good on the AI side, and now we're trying to increase it on the robotics side as well.
Okay, so I think on our side in Poland, it's still quite close to what is happening in Czech Republic. It is hard for us to get talents, especially from outside of Poland. So it is hard to convince someone that we do really, really good research and you will develop here in Poland. So people are searching like those big names, and I think they can still develop here, but it is really hard to convince people to come to Poznan. Okay, and if we follow in this topic, so if you think about those big labs, and as we had discussion with Andre, that this is sometimes really hard to implement something from other labs, especially when they are more developed. So why it is hard to transfer ideas, way of working from the labs in Western countries?
Well, the ideas are not hard to transfer itself, so you can model what they did, and this is actually quite helpful, and it was quite helpful when we built what we have, but it's hard to get into the projects, basically. It's hard to get into a research project that you are basically not at the same level or the same years of experience, and yeah, when you start something from scratch, that's the main challenge.
thing is like the methodology and this stuff, which is quite easy to transfer if the laboratory does not suffer from inbreeding, that the people are open-minded and actually travel, go around these laboratories and have visits. So yes, our laboratory has been lucky that every of the seniors has some extensive uh, collaboration or experience from abroad, which is really good. And the second thing is like regarding the research and the ideas, because it is necessary to get out of the tracking research zone, like only tracking what the biggest labs are doing and trying to implement it. It's just okay. Maybe I don't have these resources. I don't have that much of people, but I can still be good in some specific area of my choice. That's, for example, the part my colleague is working on with the time domain maps and semantic exploration and this stuff. So it's something that is not yet done by the big labs, and he can be good in it.
Okay. So, from my perspective, what is happening here, I think it's the problem of implementing things from other labs is the, let's say, changing the mindset. So building the confidence of people working here. So they are not afraid of doing big things. So because I think we have the same pool of talents more or less, but we are still shy that we can do the big things. So changing this mindset, because when you go to those big labs, they are saying, okay, we're gonna change the world, we're gonna write the best paper, and this is still not the case in our lab. So we need to change the mindset to get more confidence in what we are doing. Okay, so we are reaching almost the end, so we would like to somehow wrap up, and in a positive way, of course, right now. So what is your idea about cooperation with each other who are present in this room? So what do you think, how we can exploit the strength that we have to build something larger, let's say, or stronger?
Okay, so from my side, I believe that it is necessary to have this experience from other labs. So go there to the lab, go to the conferences, talk with the people, and most importantly, cooperate with the people. So if you found someone who has similar topic, don't be afraid to ask him, hey, I get an idea, let's write a paper and implement these things, like locally. And I also like the idea of challenges, because the challenges bring together a lot of different groups, a lot of different teams, and it helps to get recognition in the first place. The big labs are actually starting to recognize, okay, there is a team which is actually from some unknown university, but they are good at what they are doing. And in the university, we have different teams that are good in what they are doing, and just be the next team which is good in what they are doing, in the way they are doing it. So, and the competition can help in that, I guess. So get into competitions with other labs, share the ideas, because then there are always the wrap-up sessions for these competitions, and a lot of papers at conferences. So it can bring people together, and you can get into the projects and get also into the cooperation with these labs.
And Andrei, after listening to presentations, what do you think might be the joint theme for us? Or?
Sure. So, of course, what you said is very important. So, for example, I saw your national computing center. It's quite good. I would love for my students to see that as well. I'm sure they would get a lot of ideas. I already have some. So, the hands-on experience transfer is really good. And also, what I would like to focus on most is have research projects together where each of us brings to the table what they're best at. So for example, we're pretty good on the AI department because it didn't require a high infrastructure. We just did that in the cloud. But on the robotic side, it's ideally for us, we would join a project where we bring the AI side and the other side, or maybe the robotic side, and we till the end we all learn from each other basically and what we're best at.
Okay. So from my perspective, I would like to the things that we are doing already, to add those two things which are not well developed at our side, is I would surely like to push more our students, our group towards the competitions, so they can like hands-on experience that science is not always working in the wild. And also the other thing, which is also not exploited much in our case, is this reaching the alumni. So we've got really huge pool of people outside who are willing to help the university, but they don't know how. So we really need to reach them and tell them, okay, we are doing good stuff, please come and help us, even with the mentoring or some support or the network. So I think it is really good to have them. So thank you, Andrei, for those ideas, and also Peter for showing about all those competitions and how well you are doing in those. Saying that, I would like to also thank our speakers. Still, there's some time for questions. If someone wants to ask a question, please feel free to ask.
Yeah, by the way, a quick comment on the alumni. Yes. So it's actually a good idea because this is something we realized in the last years. And one of the shocks we had is that we always went for the big alumni, so the ones that had great success, and they were cooperative. But after that, we reached to the everyday programmer as well, and most of them were willing to help, maybe devote some of their time to mentoring or maybe donate some money. But they were actually quite active, so I really recommend doing that.
Thank you very much. Do you have any questions? Okay. So if there are no questions, for one more time, I would like to thank you for coming and discussing. So thank you very much.